Hello, everyone. Welcome to another episode of Geoscience Explorer. Planets rotate around our sun at different rates due to a combination of the sun's strong gravitational pull and each planet's inertia. Today, let's begin our tour of the solar system by looking at the closest planet to the sun, Mercury. Mercury, being extremely close to the sun, races around it faster than any other planet. But ironically, even though it orbits quickly, Mercury rotates very slowly on its axis, and that difference sets the stage for nearly everything unusual about this planet. Mercury gets its name from the Roman god Mercury, the swift messenger known as Hermes in Greek mythology. The name fits its rapid orbital speed, but not its rotation speed. Mercury is a small, rocky planet, only about 1.4 times larger than our Moon, making it the smallest planet in the solar system. Because Mercury lies so close to the Sun, you might assume it's the hottest planet. Surprisingly, Venus holds that title. But Mercury still experiences some of the most extreme temperature swings of any planet. During the daytime, Mercury's surface can reach a scorching 800 degrees Fahrenheit. But at night, when the sun dips below the horizon, temperatures can plummet to a freezing negative 280 degrees Fahrenheit. Why such a huge change? Well, Mercury rotates very slowly. Earth completes one rotation in 24 hours. Mercury takes 176 Earth days to experience one solar day, meaning from one sunrise to the next. That means one side of Mercury can face the sun for months. As sunlight pounds the surface, the dark, rocky crust absorbs enormous amounts of heat. But once that same region rotates into night, there is no heat source for months, allowing the surface to radiate its warmth into space and drop to extremely cold temperatures. The intense cooling happens because Mercury has an extremely thin atmosphere, called an exosphere. Unlike Earth's thick, insulating atmosphere, Mercury's exosphere cannot trap heat. It's made mostly of sodium, oxygen, hydrogen, helium, and traces of potassium. But atmosphere is often misleading. It's more like a faint cloud of particles blown off the surface by solar radiation. With almost no air pressure, heat escapes instantly. No winds form, and no clouds or weather exists to move warmth around the planet. Mercury is a world where each region experiences extreme isolation from the rest of the planet. One surprising fact: Mercury has a massive iron core that makes up 80% of its radius, the largest core to planet ratio in the solar system. You might expect this huge metallic core to generate a powerful magnetic field, but Mercury's magnetic field is actually very weak, only about 1% as strong as Earth's. Why? Scientists believe most of Mercury's core has cooled and solidified over billions of years. Only a thin outer layer of liquid metal remains molten, and it doesn't circulate vigorously enough to create a strong magnetic dynamo. A magnetic dynamo is the process where a planet's spinning, swirling liquid metal core generates a magnetic field, so slow rotation weakens the dynamo effect. Even though Mercury is metal rich, its core doesn't generate the same magnetic strength that Earth's active churning core does. Mercury's terrain looks similar to that of our Moon. The surface is covered in craters, ridges, cliffs, and ancient volcanic plains. These features tell the story of a planet that was once geologically active, but has been mostly still for billions of years. One of the most dramatic features is the Caloris Basin, an enormous impact crater about 960 miles wide. When the asteroid struck, the shock waves were so powerful they traveled through the entire planet, forming a strange, chaotic terrain. Mercury also has vast lava plains from a time when molten rock erupted onto the surface, covering huge areas in thick volcanic flows. These eruptions happened early in Mercury's history, when the interior was still hot. But because Mercury is small, it lost heat quickly, causing its volcanism to shut down around 3 billion years ago. With no atmosphere and no weather, these ancient features remain beautifully preserved, giving us a window into the solar system's early days. One of the most unusual discoveries on Mercury is a set of bright, shallow depressions known as hollows. These features don't appear on any other planet. The hollows look fresh and young, with sharp edges that haven't been worn down by erosion. Scientists believe they form when volatile elements in Mercury's crust, or materials that can vaporize easily, are exposed to sunlight or space radiation. Over time, these materials sublimate, or go from the solid to gas phase, and go directly into space, leaving behind pits and depressions. Hollows are a sign that Mercury is not completely dead geologically. Even today, some small chemical changes are reshaping its surface. So, how do we know about Mercury's surface? We haven't had astronauts there. Well, much of what we know comes from NASA's Messenger spacecraft, which orbited the planet from 2011 to 2015. During its mission, Messenger mapped the entire surface, discovered water ice hidden in permanently shadowed craters near the poles, detected the mysterious hollows, measured Mercury's magnetic field, and studied this planet's composition and geology in remarkable detail. After a highly successful mission, Messenger ended its journey by intentionally crashing into Mercury's surface because of running out of fuel. Mercury may be the smallest planet in the solar system, but it's packed with extremes: blistering heat, freezing nights, a massive core, ancient volcanic plains, strange hollows, and a magnetic field that barely holds on. It's a world that challenges our assumptions about how planets form and evolve. Thanks for watching, and stay tuned for more rock solid facts and stellar vibes.